Okay. All right, so one thing you'll want to review when you go through these lessons is you'll want to make sure that you have all of these properties in your notes. Okay, we covered them in a previous lesson, but again, you'll want to have them because when you're doing proofs, you will use each of these things, from time to time, depending on what your proof looks like. These are our properties we've gone over. Again, addition means you can add the same number to both sides of an equation to solve it. Subtraction means you can subtract the same number from both sides of an equation to solve it. Multiplication means you can multiply the same thing on both sides of an equation to solve. Division, of course, means you can divide both sides of an equation to solve. All of these things we have been doing in algebra. We just did them. We didn't realize maybe that there was a property that allowed us to do that. Down here we have our other properties. Reflexive is that something is equal to itself. Seems obvious, but it is a property. Symmetric is when we flip-flop sides of an equation. If A is equal to B, we can also write that as B being equal to A. Transitive is when we put two pieces together. Okay, so A is equal to B and B is equal to C. Well, doesn't that mean that then A would equal C? Okay, that's transitive when you have kind of three sections you put together. And substitution. If A is B, then we can use B to substitute for A in any expression. You will want to have these properties handy. Here are some other theorems that they add in this lesson. This theorem is the linear pair theorem. It says if two angles form a linear pair, then they are supplementary. You may ask, what's a linear pair? A linear pair is any two angles that form a straight line. So here, angles 1 and 2 are a linear pair because notice down here they form a straight line. So this takes us from if two angles form a straight line, then they are supplementary, and we can then say that they add to be 180 degrees. Okay, so that's the first theorem they added. The next one was the congruent supplements theorem. It said if two angles are supplementary to the same angle, then the two angles are congruent. Okay, so if angle 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary, then 1 and 3 have to be the same angle. Okay, which makes sense. Supplementary means two angles that add to be 180. Okay, so if angle 1 plus angle 2 is 180, angle 2 and angle 3 add to be 180. Well, let's say that angle 2 is 50. Well, it forces there's only one number that adds to 50 to get 180. There's only one number that adds to 50 to get 180. These 1 and 3 would have to be the same number. There's no other way to get 180. Then the only way to do it is to add it to 130 if you're using addition. So it forces angle 1 and angle 3 to be the same. Okay. And here's two more. So this one, the congruent complements theorem, is just like the supplementary one, only it's complementary. So again, if angle 1 and angle 2 are complementary, meaning they add to be 90, and angle 2 and angle 3 are complementary, meaning they add to be 90. And let's say we knew the measure of angle 2, let's say it's 40. If angle 2 is 40, notice angle 1 and angle 3 have to be the same number because the only way to add to get to 40 is to use the number 50 to add to it. Okay, so it forces angle 1 and angle 3 to be the same. And finally, the right angle congruence theorem. It says all right angles are congruent, which should be obvious. Right angle means you are 90 degrees and nothing else. So if you have two right angles, they have to be 90 each. So they have to be congruent because they are going to be 90, which means they're the same size. Okay, so those are some theorems that were added and you'll want to have at least reference to so that you recognize what they mean and are able to place them in proofs.